Okay guys, today we're going to talk about section 3.4. It's in the text. It's all about solving rational equations and radical equations. So, to state the obvious, equations that contain rational expressions are called rational equations. And equations that contain radical expressions are called radical equations. And each one of these is dealt with a little bit differently, and we're going to start by talking about rational expressions and equations. Now, when you're working with rational equations, the idea is to clear the fractions. And you do this by using the common denominator. And once you get rid of the fractions by using that common denominator, it's actually pretty easy to simplify or to solve for the equation. Now, there's a note in your textbook on page 273. It says caution. The caution simply states that you only clear fractions when you're working with equations. Equations meaning that there's an equal sign involved. You cannot clear fractions when you're working with just expressions. Don't forget that expressions are simplified and equations are actually solved. And again, you only clear fractions when you're solving a rational equation, okay? There's a nice example. It's pretty clear cut on page 272. It's in the blue boxes there. It shows you the algebraic solution for a simple example, and then it actually helps you to visualize the solution. And what I think is important to note is that when you're solving rational equations and you end up with x equals something, what you're doing is you're finding the x coordinate on the axis where your graph is crossing the x-axis. So, again, it's important to be able to visualize these things graphically as well as algebraically, so make sure you take a look at that example. I'm going to take a second and run through a quick example on page 274. It's example 2. The example reads x squared divided by x minus 3 equals 9 divided by x minus 3. This is just a really simple illustration of how we clear the fractions and then just work with what's left in the numerator. So if you look at both of these rational expressions, there's an expression on each side. With the equal sign, it makes an equation. You see that the common denominator is x minus 3. So the idea is to multiply the entire equation by x minus 3. It's sort of a distributive deal. When you distribute that to this, your x minus 3's cancel and you're left with x squared. When x minus 3 is distributed to this other expression, the x minus 3 cancels as well. You're left with 9. This is a simple quadratic. You can use roots to solve it. So the idea would be you take the square root of both sides, and the square root of x squared is x. The square root of 9 is positive or negative 3. Don't forget that when you're working with a quadratic equation, you often, not always, you often have two solutions. So what we have just shown here is that if we were to graph this, even though this is not, or perhaps not a parabolic function, you would have an intercept at 3, and you would have an intercept at -3. So whatever this graph looks like, it would cross the x-axis at -3 and 3. Example 3 is probably a good one to go through as well. So let me get this off the board here. We'll go through that. All right, example 3 reads 2 divided by 3x plus 6 plus 1 divided by x squared minus 4 equals 4 divided by x minus 2. This equation clearly is not as simple as the previous one because there's not an obvious common denominator here. So the idea is to factor each one of these denominators and try and find the common components of each one. So, factoring the first expression, we can say 2 divided by 3 times x plus 2. Your second expression, it's a difference of squares, so you have x plus 2, x minus 2, equals 4 divided by x minus 2. All right, so common components within each denominator. This one has a 3, so that has to be included in the common denominator. X plus 2, that clearly has to be included. So we've included everything here. Jumping over here, we have the x plus 2 already. Now we need the x minus 2. And that's clearly covered here as well. So you're looking for the components that are included in all three denominators. So what we're essentially going to do is multiply this whole thing by the common denominator. So when you look at this first expression, you have 3 and x plus 2, so those would cancel. You're left with x minus 2. So what you have is 2 times x minus 2. The second expression, your x plus 2's would cancel, your x minus 2's would cancel. What you're left with is 3. So plus 3 times 1. In your third expression here, your x minus 2's would cancel, so you're left with 3 times x plus 2 times 4. Now it looks like just a regular equation that you've seen in algebra at some point, and you just begin solving. Distribute first, that's always the first thing that you do. So you'll have 2x minus 4 plus 3 equals, I'm going to multiply since multiplication is commutative, I'm going to multiply the 3 and the 4 first for 12. So then I'll have 12x plus 24. Subtract 2x from both sides. Negative 4 and 3 is negative 1 equals 10x plus 24. Subtract 24 from both sides, so negative 25 is equal to 10x. Divide both sides by 10, so negative 2.5. X is equal to negative 2.5. Okay, so the idea with rational equations, find a common denominator, multiply the whole equation through by the common denominator, simplify as you would in a traditional algebra problem. So let's take a second and look at radical expressions. So when you talk about radicals, you're talking about square roots. And because we're talking about expressions, we're talking about more than one variable or one number under the square root. All right. So let's look at an example. Example 4 on page 275. You have the root of 3x plus 1 equals 4. Now, the idea is we have isolated the root expression, okay? We're going to use this principle called the principle of powers. And that principle of power states that if you have some two things that are equal to each other, in this example we have the root of this is equal to 4. If you raise one of those sides to a power, the other side is also raised to a power. And then you also want to remember that the square root of anything squared simply reverts back to the base. So in this particular case, all we have to do is square each side. Because the square root of something squared is just the base itself, or the expression itself. But if you square one side of the equation, you have to also square the other side. So 4 squared is 16. This should look very familiar. It should look like a very simple algebraic equation that you've seen at some point. So we're going to subtract 1 from both sides. 3x equals 15. Divide both sides by 3. X ends up being equal to 5. Done. There's a really great example on page 276. Again, it shows the algebraic solution as well as the graphical solution. You're fine, kiddo. It's always here. Take a look at example 5, and then just to run through one more example. Example 6 on page 277 is the root of x minus 3 plus the root of x plus 5 equals 4. Alright, so in this particular case, you can't just square each one of these because you have to square the entire side in order to get rid of the radical. So the idea is to again try and isolate at least one of the radicals, and we'll go from there. So I'm going to subtract the root of x plus 5 from both sides. And what I end up with is the root of x minus 3 equals 4 minus the root of x plus 5. Now that I have one of the radicals isolated, I can square both sides using this power rule and solve for x. Now, what I need you to notice on the right-hand side is I actually have an expression that includes a radical, so we're going to FOIL it. So, on the left-hand side, the root is canceled by the square. That's easy enough. On the right-hand side, what we actually have to do, just sort of taking it over here, is we're going to multiply 4 minus the root of x plus 5, 4 minus the root of x plus 5. It's going to be FOIL. So 4 times 4 is 16, minus 4 root x plus 5, minus 4 root x plus 5, plus this times this is x plus 5. So you have 16 and 5, which is 21, minus 8 root x plus 5 plus x. So we have 21 minus 8 root x plus 5 plus x. Move everything over to the left-hand side, and then we can take the square again. So I'm going to subtract x and subtract 21. So x minus x, those zero out. So we have negative 24 equals negative 8 root x plus 5. Divide both sides by negative 8. So we have positive 3 equals root x plus 5. Now we're back to sort of the beginning, if that's what you want to call it, where we have a radical that's isolated. So square both sides. 3 squared, well, let me show you. 3 squared is 9. This equals x plus 5. Subtract 5 from both sides. X ends up being equal to 4. Okay, and that's section 3.4.